Let me talk a little bit about the Ferris wheel here. If you look at the reference on the Oaks Park website, this distance here is 9.4 meters, which makes that a pretty big Ferris wheel, right? What we can do, one of the things you can calculate is you can just calculate the tangential velocity, and that would be one circumference, right? So 2 pi r, that would be your 9.4 meters, right, over the period. And you could have either timed the period when you're at Oaks Park. I have another video right close to this one that shows you how to get the period off of the video. Try to use a video from the year that you're using it to actually determine the period, right? Right, so you could figure out the tangential velocity. That's how fast you're going. Probably the coolest thing though to do would be to figure out the actual acceleration, the centripetal acceleration. The best way to do it on the Ferris wheel is to use 4 pi squared r over t squared, right? And again, this r here is your 9.4 meters, right? This period you can get by either having timed the Ferris wheel or you can get it off of a video. I show you how to do that in another thing, right? But remember that this is a vertical circle, right? So on the average, we should be pulling about 9.8 meters per second squared of g-force, right? Okay. At the top, though, you're going to be a little bit lighter by this amount, right? So it's going to be, you're going to feel 9.8 minus whatever that centripetal acceleration is, and it's not big. It's like half a meter, right? Half a meter per second squared. And at the bottom, you're actually going to feel a little bit heavier, okay? So it's going to be 9.8 meters per second squared plus that centripetal acceleration, right? Here's some really pretty data that we got. Oh my gosh, I drew on that. Okay, we got this data from Oaks Park in 2012, and that's really pretty here. I mean, basically this is what our 9.8 is, something in here, right? This thing actually, I think if you average it, one thing you might want to do is just take a chunk of this and average it, like go from a peak to a trough or something. I think it averages out to be like 9.73, which means our accelerometer wasn't quite calibrated, right? But you can go in here and look at this. Here's your 9.8. Here you are at the bottom of it, right? You're a little bit more than 9.8 by about a half a meter per second squared. Here you are at the top. You're a little bit lighter. Okay, so you could actually figure out how high these are, right? Figure out what that is, right? Ta-da! Right, figure out what that is. Right, figure out what the average is. What is the average? Somewhere in there, right? You know, and then you can figure out what, how much above, how much below it is, right? Okay, that again, that should be your centripetal acceleration, right? It should be the 4 pi squared r over t squared, right? You should be able to get that from that. Now, if you want to be super advanced, right? If you want to be super advanced, you could do something like this, like y equals, for this graph, right? If this is y this way, right, and this is x this way, right? Okay, well, y equals some y naught, that'd be this thing, right? Plus some amplitude, right? That would be this, right? The acceleration, right? Sine of some omega, right? Times x. X is really time. I'll say t. Let's just say t, right? Okay. Plus some phase shift. I would just call it theta naught, right? Okay. And so you could just make a spreadsheet like this and see if you can plot these points, right? Your omega is going to be what, 2 pi over the period. Right, I made a spreadsheet. It actually matches up. It makes a nice little sine wave like that. If you mess around with these parameters, right? So this is just you got to pick that, right? Obviously, it's not starting out as sine. It looks like negative sine or something. For a, I guess that it was like half a meter per second squared. I made this to be like 9.73 or whatever the average of this is. Anyway, try that. I think I used a 2 there. That ended up being 2 pi over 24.6. This ended up being, actually what I did was I figured out this, right? But if you make your own model and put this in Excel and put the model on top of that, I'd be very impressed. But you know, just any analysis of this would be cool. Just some ideas.